Okay, so next we're moving on to question number 7. In question number 7, as you can see in the question, it's given that bags of sugar are packed in boxes, each box containing 20 bags. The masses of the boxes, when empty, are normally distributed with mean 0.4 kg and standard deviation 0.01 kg. The masses of the bags are normally distributed with mean 1.02 kg and standard deviation 0.03 kg. The first question then is to find the probability that the total mass of a full box of 20 bags is less than 20.6 kg. And the second question is two full boxes are chosen at random. Find the probability that they differ in mass by less than 0.02 kg. Okay, so now let's look at the solution to this question. Okay, so in this case we are given x has a normal distribution with mean 0.4 and variance of 0.01 square. So this is a box's mass distribution kg. Okay, and that's represented by variable x, and variable y represents bag's mass distribution in kg. So, and it's also a normal distribution with mean 1.02 and variance 0.03 squared. Now let m be the mass of a box containing 20 bags. Assuming that the masses of the boxes and bags are independent, m will be normally distributed with mean and variance given by. Now in this case what's happening is the distribution for bags and distribution for boxes are given, and so you want to find the total mass, right? So total mass, I'm representing it by m. Okay, and so in this case if you look at it, you find that the expectations of mass, okay, is given by E x1 plus y1 plus y2 plus y3. So here x1 is the boxes, okay, it's the box that we're considering, and y1s are the bags, and since there are 20 bags we have to add up all of them up to 20. And by using the rule, expectation rule, we know that this is this, right? So expectation of x1, expectation of y1 plus, and so on up to expectation of y20. And expectation of x1 is 0.4, right? We're given in the question itself that the expectation of x is 0.4, so that any mass you take has an average mass of 0.4 and the bag's mass is of 1.02 kg. And so if you add up everything you get 20.8 kg. Now for the variance, it might get a little bit tricky if you don't pay attention here carefully. Okay, now because these bags are independent, okay, you choose them one by one, so you cannot write 20y. You have to add up individually, okay, because finding a variance by writing x1 plus 20y1 and adding up all of these and finding the variance gives you totally different answers. So that's one thing you have to keep in your mind. So then variance of m is just variance of x1, variance of y1, and so on up to variance of 20. So obviously by formula, you know the variance of x1 is already given in the distribution, so you just add up all of these. Okay, and then you get this one. And the reason why I'm saying you cannot write 20y1 is because according to the variance combination of the variables, the variance would be variance of x plus 20 square variance of y1. Okay, so but in this case it's not 20 square, it's 20. So that's the difference here. So this is the variance then, 0.018. Now So then we have M to be a normally distributed with mean 20.8 and a variance of 0.0181. Now the first question is asking us to find the mass to be less than 20.6. So again, if you standardize it, you want to find PC is less than minus 1.4865, so you get this one. It's very important when you are finding the value for the probability, you have to standardize for a normal distribution, and hence you get 0.0685. Okay, let's move to the second part of the question then. Okay, we have to find the probability that the masses differ by less than 0.02. Now, because we know that M is normally distributed with this parameters here, 20.6 as a mean and 0.0181 as a variance. Now we are introducing a new variable here, D, where we are taking that to be a difference between two masses, M1 minus M2. So that's the difference between two masses, right? So then we do the same thing again. We find the expectation of D and we find the variance of D. Expectation of D is simply 0, because expectation of M1 is 20.6, expectation of M2 is 20.6. 20.6 minus 20.6 is 0. Right? So again, you find the variance of M1 plus variance of M2. Now the important point to note here is, even though this is minus here, when you find a variance, you have to square it, right? So minus 1 whole square will give you plus, so hence there'll be a plus sign here and then variance of M2. Okay, then we have our new variable D, which has a normal distribution with mean 0 and a variance of this. So it's very important to remember that we are asked to find the probability that they differ in mass by less than 0.02 kg. It could be a positive difference, it could be a negative difference, we don't know, but it has to be within a 0.02 from the mean. Okay. Now, if you want to find this one, you have to use a modulus sign. So modulus of D is less than 0.02 implies that your mass is varying within 0.02. So by definition of the modulus, you can write this expression inside as this, right? So once you have this, it's pretty straightforward to find the value of the probability. So this is the diagram that I've shown it to be a visual version of the solution. So again, you basically standardize this here by here. Okay, so minus 0.02 minus 0, the mean is 0 here, and the standard deviation will just be the square root of the variance. And if you look here, so okay, so from here you have this here. So this is just PC is less than 0.015 minus PC is less than minus 0.105, right? Because less than probability here minus less than this will give you in between here, the shaded region. And hence, what you can see here is basically the simplification. You can use calculator to do this one. You can look at the table and then you find that your answer is 0.0836. Okay, so that's about it. And that's question number 7. If there is any questions that you don't, if there's any part of the solution that you don't understand, you can contact me. I'll be more than willing to answer. Okay, see you. Bye.